So I'm assuming it is recording. I just can't hear. Yeah. Is that right? Okay. Something like that. All right. Just to reiterate, we are going into chapter 7. It's going to be a blitz because it's really majority of at least this week is not going to be too much thinking. You just have to sort of know it. And then at the very tail end, I might have you practice some thinking questions based on what you know. This Friday is going to be a very quick quiz. I have designed it for essentially 20 minutes, but I'm going to give 30 minutes for it. If you think you do need the extra time for those who are eligible, well, we'll figure it out then. We'll see how much you can do in that 30 minutes. Next week is Victoria Day, and the remaining 4 days is essentially chapter 7 review. I'm going to propose to you kinds of questions that exponential laws help us with. Because ultimately the question is, why am I doing exponents, right? Why am I learning this? And I'm going to try to show you how even something like this, there is a place for it in the outside world, not these 4 walls, okay? The reason why I have to take some extra time to do this is because chapter 8 is all about using exponents, but in the context of money, interest, investment, you name it. Okay? And so that is why we have this. So today we'll start the exponent laws. I get through as much as I can, and hopefully you'll have some time to work on your assignment. Any questions? No? Any concerns? Any weekend issues? Okay, let's get to it then. I have for you, so here is our document. All right, so intro to exponent laws. In short, I'm going to try to get through all 4 of these today, but I think it's typically, no, I think just an extension of these first 3, and then we'll get into 4 and 5 tomorrow. But anyways, here's my explanation. Everyone with me? When where's my annotation? Okay, here we go. When you have an exponent, first, it's good to know what the exponents are. So on this, in this little space here on the bottom, would you follow with me? Let's pretend I have some kind of exponent, some kind of power. I have a base to the power of, let's say, x. And that this entire power also has a number multiplying in front of it. Could you copy this down for me? It's a times b to the x. That's how I would read it. I need you to be comfortable with some words I'm going to use and how I describe it. Pop quiz. What would you call this? Would you call this an exponent, or would you call this a power, or would you call it both? Any thoughts? Take a guess and be wrong. That's okay. We're getting into this for the first time. And you know what? Some teachers are guilty of interchanging those words too. Right? So some people, you could say, isn't it both? You could say, isn't it one or the other? But what do you think? Both, possibly. So this entire thing is both an exponent and a function. Okay? Anyone else have a different idea? Not sure? Well, half right. This entire thing right here, that entire term is called a power. So if I say write it as a power, this is what I mean. Write it like this. You might recognize this. There is a word that we call something that multiplies the variable term. Any number that multiplies with a variable term, we call it a coefficient. And then in a power, there is a number that has a little superscript number on top in the top right corner. Whatever that number is, We call that the base. Because that number is what I'm going to either multiply or divide again and again and again and again, which leaves me with that last term. That little number up top is called the exponent. Okay. And so this is it. Now that we have these terms, you will know exactly what I'm talking about. Take a look. Exponent law number 1. What happens when you have some exponent multiplying with another, some power, oh, I did it. I made a mistake. When some power is multiplied with another power, what do we do? Okay. Here's the condition for exponent number 1, or actually, let me explain it. When you are multiplying powers, the exponents end up adding together. Now, all of a sudden, people are like, what the heck is going on? Let me try to explain. Here are the conditions to multiplying powers. Number 1, are the bases identical? The base here is a 2. The base here is a 2. They have to be identical. Check number 2. Are the numbers multiplying to each other? Yes, the 2 powers are multiplying to each other. When that happens, don't think too hard, simply add the exponents. So do you see the exponent is a 3? Exponent is a 5. You simply add it. And that's, you might be thinking, oh, do I have to memorize another thing? This is the logic behind it. You don't have to memorize it, but as you start doing the long way, you will see that it actually saves you a lot of time. Consider this, 2 to the power of 3. 1 second, 2 to the power of 3. Would you agree 2 to the power of 3 is the same as 2 times 2 times 2? Yeah, okay. And then I'll do it in red. 2 to the power of 5 is 2 times 2 times 2 times 2 times 2. So 2 times 3, which is multiplication of 2's, and 2 to the power of 3, which is a multiplication of 2's, 2 to the power of 5, which is a multiplication of 2's, are also multiplying. So if I were to write it all out, what do you notice? Isn't it just a long string of multiplications? Since 2, okay, so 2 times 2 times 2 times 2 times 2 times 2 times 2. How many times am I multiplying it to? And you can rewrite that. Do mathematicians want to write all of this every single time? No. Since we are, I'm going to say it, lazy, you simply turn that into this. So then the question is there a relationship between 2 to the power of 3 times 2 to the power of 5 and 2 to the power of 8? Even an elementary school student will say, oh, hey, isn't 3 plus 5 equal 8? There's the law. Now, some of you are like, I'm not going to know that. I'm just going to memorize it. Sure, you can do it. Other people will say, I don't like memorizing. I need to understand it. Either way, the law applies. So here, when I give you something like this, you can say, oh, that's 6 to the power of 5 times 6 to the power of 6. You could multiply this out. 6 to the power of 5 times 6 to the power of 1. Or you can do exponent laws and say, oh, the exponents are going to add. This is 6 to the power of 6. Which way is easier for you? I do not know. But you have to choose. Okay. So quick thing, before I move on, I could do something as silly as this. If I say x to the power of 99 multiplied by x to the power of 1, what would you say? If I asked you to write it as 1 power? Okay, correct. I'm going to get a little creative now. What if I say x to the power of 99 times x to the power of -1? It doesn't change the law, right? 98. 99 is added to a negative 1. It's 98. So it's the same thing. It's the same thing. So you might wonder, why the heck do I have a negative 1? Don't worry about it. Okay. We'll get to negative exponents much later on. But for now, if I were to give you this, the law still applies, no matter how weird it is. Okay. So far, so good? Yes. Which brings us to division. How about that? Without looking at the explanation, are the bases identical? 3. 3. Yes, they are. Are the powers dividing? Yes, they are. If that's the case, subtract the exponents. So again, without looking at the explanation, first, apply it. 5 to the power of 5 divided by 5 to the power of 2. Instead of adding the exponents, we will subtract. 5 minus 2. This is 5 to the power of 3. And of course, if you want, you can plug that into the calculator and solve it. But here's the explanation. 3 to the power of 7 divided by 3 to the power of 4. Would you agree that this is equal to 3 to the power of 7 and 3 to the power of 4? Would you agree that a fraction is equivalent to a division? I hope so. Okay, so bear with me. From here, 3 to the power of 7 is 3 times 3 times 3 times 3 times 3 times 3 times 3. 3 to the power of 4 is 3 times 3 times 3 times 3. And I hope you see it. You notice that a 3 is being multiplied, but it's also being divided. So essentially, what's 3 over 3? You can simplify that as 1. So 3 divided by 3, 1. 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 All that's left then on the denominator is 1 times 1 times 1 times 1, which is 1. 1 times 1 times 1 times 1 times 3 times 3 times 3. I have a 3 over 3. So here's my explanation. You could write it out if you want to. You can memorize the rules if you want to, but it doesn't change anything. It doesn't change the answer. Please note, I believe, if I remember correctly, exponent laws are first introduced, at least in high school, in grade 9. So you may have seen this before, but you may have constantly been tricked by the teacher trying to be sneaky with you. I hope that you will be able to be assured that I'm not going to try to trick you per se, but I still will ask you straight up questions like, hey, don't use a calculator. Tell me what this is. And I'll ensure that you're not using a calculator by giving you things like a to the power of 5 divided by a to the power of 4. And what would that answer be? Yep. Or just a. Because a to the power of 1 is multiplying just once, right? Like it's just a, right? So that's exactly it. And again, same thing. How about I get a little tricky with you, Brendan? A to the power of 5 divided by a to the power of -4. Ooh, that is 5 subtracted by what? A -4. So what's the answer to that? Yes. So again, why would you have a negative exponent there, Mr. Kim? I know. But regardless of what kind of numbers are there, the rules still apply. Okay? Any questions for the first two? So as a recap, If you have a power multiplying with another power with the same base, the exponents will add. If you have a power dividing by another power with the same base, the exponents will subtract. Two more. Exponent law 3 and exponent law 4. Exponent law 3 is how we deal with terms that have a power on a power. Take a look at exponent number 3. What do you do when you have a power? So this is 3 to the power of 2, but all of that is to the power of something. Short form, exponent law tells us that if you have a power of a power, so powers of powers, the exponents will multiply. So in this case, 4 to the power of 2 is to the power of 3. What happens? Exponents multiply. So what do I write here? Which is, and if you want to try that out, if you don't believe me, 4 to the power of 2 is 4 times 4. I can't actually do 16 to the power of 3 in my head. 16 to the power of 3. Using a calculator, this becomes 4,096. 4 to the power of 6, I'm just going to plug it into the calculator. Same thing, 4,096. You try that using a calculator. So what is my reasoning? My reasoning is this. You have to remember your exponent law number 1. Eyes up here. Zach, exponent law number 1. Could you recap for me? If you have something to the power of something multiplied by something to the power of something, what happens to the exponents? Correct. I need you to remember this because it's going to be used right here. Take a look. 4 to the power of 2 is to the power of 3. And I'm going to open it up. This is 4 to the power of 2 multiplied with itself, multiplied with itself. Would you agree? Are these powers? 4 to the power of 2. Is that a power? Yes. Do they have the same base? And are they multiplying? What happens to the exponents? What happens to the exponents? So this is 2 plus 2 plus 2. What does that equal? 4 to the power of 6. Do you see it? So do you want to write it out like this? You could. You absolutely can if you want to. If you don't want to, then remember that having a power of a power, you have to multiply them. Okay. So once again, then, as a summary, if you have an exponent multiplying with an exponent, it's added. If you have an exponent dividing by an exponent, it's subtracted. If you have an exponent on top of an exponent, so a power of a power, they are multiplied. It's so easy to get it confused. So we're going to have to practice to build that skill. And here's the last one before we turn to the last page. Ready? Anything to the power of 0 equals not a 0. What do you think? Remember? 1. That's number 4. This is exponent law number 1. This is exponent law number 2. This is exponent law number 3. And this is exponent law number 4. We're done today's lesson. It's just a matter of practice. Let me do a quick explanation of number 4 in the next page. And then we're going to do some practice questions together just to get, dip your feet into it, get your feet wet. And the rest of class you can use for your assignment. I thought I saw a hand in the back somewhere. Is that a hand? Okay, let's move on then. Here's my explanation of number 4. So instead of just trying to convince you, I'm going to give you a bunch of examples instead. You have to remember your exponent laws though. You ready? 5 to the power of 1 divided by 5 to the power of 1. We can use our exponent laws. What does our exponent law say when you are dividing powers of the same base? What do you have to do with the exponent? Subtract. So using that, wouldn't it be true that I say this is the same as 5 to the power of 1 minus 1? Would you agree? I'm subtracting exponents. So this is 5 to the power of 0. Okay. But if I were to use normal arithmetic, like elementary school arithmetic, what is 5 divided by itself? 1. So did I just not prove that 5 to the power of 1 divided by 5 to the power of 1 is 5 to the power of 0, but it's also equal to 1. So then doesn't that mean 5 to the power of 0 and 1 are equal to each other? It's like A equals B, but B equals C, so B and C are equal. Sorry, if A equals B, but A equals C, that means B and C are going to be equal. That sort of makes sense, I hope. We'll try it again. 3 to the power of 1 divided by 3 to the power of 1. It is 3 to the power of 1 divided by 3 to the power of 1, right? It's a power divided by a power. So the exponents will subtract. This is 3 to the power of 0. But if you use normal arithmetic, 3 divided by itself is equal to a 1. Therefore, it makes sense to say that 3 to the power of 0 equals 1. And if that's the case, I could do anything I want, right? Clover to the power of 1 divided by clover to the power of 1 is the same as clover to the power of 0. But anything divided by itself is equal to a 1. So a clover to the power of 0 is equal to a 1. And lastly, even if I didn't know the base, if my base was a variable like b, b to the power of 1 divided by b to the power of 1 is like b to the power of 1 minus 1, which is equal to a 1. So there's my explanation. There are other ways I could do it for sure, and maybe we'll take a look at that. But right now, I'd like us to dabble into some questions I might give you for the test, for the quiz. This is literally questions I might give you for the quiz. Looking down, how about I do a little bit of everything? I'm going to do A, I will do B, I will do C, just to get your feet wet. And then let me do E and F as a challenge. The rest is yours to solve. Here we go. Simplify. Do not calculate. I don't want the final answer. I want to write it as a single power, please. That's my goal. I actually don't want the answer. If you give me the answer by a calculator, I'm going to say, I'm not looking for that. You don't get your 1 out of 1. Here it is. Are the bases the same? Yes, they are. Are they multiplying? Yes, they are. What do I do with the exponents? That's it. Negative 3 to the power of 2 times negative 3 to the power of 3 is negative 3 to the power of 5. Done. You are not multiplying them. It's not 2 times 3. It's 2 plus 3. Next one. 6 to the power of 8 divided by 6 to the power of 2. Aiden? 6 to the power of 6. It is not 6 to the power of 4, okay? It's not 8 divided by 2. It's not 8 divided by 2. It's 8 minus 2. Please be careful. Okay. What about now? Look carefully. Charlie? Negative, oh, sorry, -5 to the? Yeah, it's a power of a power. An exponent is on top of it. So it's actually 2 times 3. It's a 6. Now is a good time to multiply, not the previous. Which brings us to the next one. Woohoo! You could do it in one go, and I'll do that here. But let's take it step by step. Assuming that we do the numerator and simplify the numerator first, what does the numerator become? 4 to the power of, are you with me? Or not? Never mind. You all right? Okay, bases are the same. Multiplying, yes. So exponents will becomes 4 to the power of. Okay, and then I'm going to copy this on the bottom. Now what happens? Now it's a division. But if you think about what we did, we added and we subtracted. Seeing this, you can actually rewrite this as 4 to the power of 9 plus 3 minus 5, all in one go, if you wanted to. Because that's what it means, right? This right here is 4 to the power of 9 multiplied by 4 to the power of 3. And that entire thing is divided by 4 to the power of 5. Like that's what's happening. So you can actually rewrite it as a single power with all of those exponents in one go. And that brings me to my challenge question. Take a look at this. Yep. Oh, yes, I do. 30? Well, let's test it. I actually haven't done it, but let's take a look. Huh? 3, sorry. There you go. Okay, so let's slowly work it out. Number 1, are all the bases the same? Yes. So I can use my exponent laws. What's happening then as I try to use my exponent law? We have -2. Notice how the negative is a part of a bracket. It's all part of the base. So don't lose the bracket. -2 is to the power of 4 to the power of 3. So what happens to the exponents? Sage, you with me? Sort of? Do you know what would happen to the exponents? No? It's a power of a power. This is exponent law 3. They do. 4 times 3 is a 12. And then the bottom, careful, a power is being multiplied to the power. So what happens to the exponents? They're not multiplying. Yeah, go ahead, Brendan. They add. And then so I have another division. So Alex got it. It's -2 to the power of 3. So part of the exponent laws is not to try to make life hard for you. Mathematicians are firmly convinced that this is a lot harder than this. Wouldn't you agree? Right? So these exponent laws were actually meant to try to make your life easier by simplifying something that obviously looks more complex. But that requires you to know how to deal with exponents. So that's the problem. It's like, do you want to deal with the hard stuff for the rest of your life? Or do you want to improve your skills so that you can always make it easier for the rest of your life? But that requires putting in some effort up front, obviously. Okay. These are the exponent laws. These kinds of questions. So number 2, and if you flip the page, I have some quote unquote challenge questions to see what you can do for number 3, number 4, and number 5. I would like to see you try more of these questions. I'm going to do this one with you. What if you have something like this as a fraction? And then I do C with you, okay? What if you have something like that as a fraction? All of a sudden you might think, oh, Mr. Kim didn't teach me fractions. No, not necessarily. Are the bases the same? Yeah. So this is actually that. The bases are the same, right? Don't get it confused, and don't get worried about it. 2/3 is the base. Right? That's how you simplify. Of course, if a question asks you to evaluate, well, that means it's 2/3 times 2/3 times 2/3 times 2/3 times 2/3. That actually equals 2/5/3/5. And you could actually plug that into the calculator. Right? Do you notice how in the numerators, we are multiplying 2, 2, 2, 2, 2. And in the denominators, we're multiplying 3, 3, 3, 3, 3, if we were to multiply. And so 2 to the power of 5, I can do that in my head. But 3 to the power of 5, 3, 9, 81, 243. Okay? And I expect you to just leave the fraction as that. You don't have to try to solve it. If I were to ask you to evaluate, but most likely on this quiz, I will not. I just want to see your exponent laws, so don't worry about it. What about this one? Oh, Mr. Kim, you gave me a fraction. No, it's the same single base, but with a power of a power. I'd like to see you try it. The very last example I want to do with you is this bottom one. How do you deal with, what is it? How do you deal with, I guess, powers that have multiple bases? Here's how we do it. Last one, okay? This is for C. Please be advised that I'm not trying to trick you. The question is simply asking, a 5 is a coefficient multiplied to x to the power of 5 and y to the power of 2. The denominator is a 10 as a coefficient and x to the power of 2 multiplied by a single y. If you are wondering how to deal with this, the only way you can use exponent laws is if the bases are the. So do the exponent laws here, just for those two. And then, do you notice that the y's are also the same? The bases are the same, so do the exponent laws for those separately. And then lastly, I have coefficients, so do normal arithmetic with the coefficients. Oh. 5/10. It's a 0.5. I'm actually going to reduce it like it was a fraction by dividing top and bottom by 5. This is 1/2. And what is, actually, maybe I shouldn't do that, just 1/2. Multiplied by, what is x to the power of 5 divided by x to the power of 2? Exponent laws. Divided by 2. X to the power of 5 to be divided by x to the power of 2. Yes, there's subtraction. And then y to the power of 2 divided by y to the power of 1. 2 minus 1, 1. So the final answer is this, or if I were to keep it as a fraction, all the whole numbers are going to be on top and the denominator of 2 is on the bottom. Both of these are okay. I just want you to see that the exponent laws still apply no matter how funky looking it might be, as long as the bases are the same. Even here, those are bases and those are bases. So P and Q, P to the power of 6 divided by P to the power of 3, solve that. Q to the power of 5 divided by Q to the power of 2, solve that. If I were to rewrite it, this is P6Q5, all divided by P3Q2. Use your exponent laws. It's not meant to be, it's not meant to make your life harder. It's supposed to make your life easier. But of course, as I said, to make your life easier, you need an extra piece of knowledge, and that might be annoying. Any questions? Okay. And my expectation, I hope that you will be able to finish off the examples that I haven't done in this sheet. And in the next page, if you feel comfortable, I feel like you can save all of questions 5 to 8 or 5 to 9 even for your quiz. I would like you to try number 10 as a challenge. This is a T question. So could you put a star next to number 10 and see if you can try that before you come tomorrow? Okay.